Today, we're diving into a technology that is, and I'm not exaggerating, completely revolutionizing one of the world's most complex industries, aerospace. We're talking about digital twins, and you're about to see how they are changing literally everything, from the drawing board to the skies. But, to really get why this matters so much, we have to start with a pretty basic question. Why on earth does it take decades and billions upon billions of dollars to build a new airplane? It's this massive, massive challenge that really sets the stage for the incredible solution we're about to explore. And that challenge, well, we can call it aerospace's billion-dollar problem. The thing is, as our planes and jets get more and more advanced, the whole process of actually creating them gets way, way harder. I mean, just look at a project like the F-35 fighter jet. It's the perfect example of this problem. The more sophisticated the systems get, the more time and money you have to pour in. You have to physically build prototypes for every little thing, test them, literally break them, and then learn from that failure. It's just this long, incredibly expensive cycle. So how in the world do you break out of a cycle like that? Well, this is where the hero of our story makes its entrance. Say hello to the digital twin. This is the innovation that's ready to tackle aerospace's massive problem head on. So what exactly is a digital twin? Well, put simply, it's a perfect virtual copy of a physical object. It could be a twin of something small, like a single bolt, or something huge, like an entire aircraft. But here's the magic part. It's synchronized with the real thing, constantly fed data, so it acts, behaves, and reacts just like its physical counterpart. And right here, this shows you the fundamental shift in thinking. The old way is all physical, it's slow, and it's reactive. You build it, you break it, you learn. The digital twin way, it's virtual, it's lightning fast, and it's predictive. You can run millions of simulations, tweak the design in the digital world, and the ultimate goal? Build it right the very first time. All right, so let's actually see how this plays out. We'll follow an aircraft's life starting right at the beginning, the design phase. This quote from Stephen Wood really just nails it. Just think about it for a second. Imagine being able to test every single thing about a new jet engine, how it handles heat, its stress points, its performance, all without ever building a single physical part. The amount of time and money that saves is just incredible. And the potential savings, they are staggering. 50%. Yeah, you heard that right. According to the experts, that's how much you could potentially cut down both the time and the cost for these massive international projects, like the Global Combat Air Program. I mean, cutting a multi-billion-dollar project in half, that's an absolute game changer. Okay, so you've designed the perfect aircraft in the digital world. Awesome. But now you have to, actually build the thing. And it turns out digital twins are revolutionizing the factory floor too. So get this. Before you even pour the concrete for a new factory, you can build a digital twin of the entire factory. You can play around with layouts to find the most efficient workflow, simulate which machines you should buy, and even run what-if scenarios. Like, what happens if a key supplier in your chain is late? You can test that in the digital twin and have a backup plan ready before it's even a real-world problem. And as Todd Tuthil from Siemens points out, it's really all about making manufacturing smarter and way more efficient. By feeding real-time data from the actual factory floor back into its digital twin, you create this amazing, continuous loop of improvement. So, the aircraft is built, it's flying, but the digital twin's job? Oh, it is far from over. In fact, this might be where things get really interesting, because now we're talking about predicting the future. Think about all the new tech going into planes, like electric powertrains. These are often totally sealed systems. You can't just pop the hood and take a look like you can with an old car engine. The digital twin, though, which is constantly getting data from sensors on the real engine, it basically acts as your eyes. It lets you see inside and predict when maintenance is needed before something actually goes wrong. All right, I'm going to throw a number at you that tells a really fascinating story. 30,000. Any ideas what that could be? That's the number of high-tech, incredibly expensive turbine blades that one company had to just set aside every single year. And not because they were broken, it was because their shape wasn't 100% geometrically perfect when they were scanned. We're talking about a huge amount of potential waste here. So what do you do about that? Well, this is where it gets really, really cool. A company called PhysicsX combines digital twins with artificial intelligence. As their engineer Neil Cameron explains, They train an AI to predict how a digital twin will perform, and it can do it almost instantly.
So, the new process is just brilliant. You take one of those so-called imperfect blades and you scan its totally unique shape. Then, the AI-powered twin simulates how that specific geometry will perform aerodynamically in the real world. And boom, in less than a second, you get a decision based on data. Is this part good to go or not?
And that right there, that is the crucial shift in thinking. Instead of being obsessed with a perfectly shaped part, you start focusing on what actually matters: real-world performance. A blade might be a tiny micron off from the design, but the AI twin can tell you that its performance is going to be perfectly fine. This saves thousands of perfectly good parts from ending up on the scrap heap. So when you put all these pieces together, the design, the manufacturing, the maintenance, you start to see that this isn't just some small improvement. We're looking at an entire industry being completely reimagined from the ground up. The takeaways here are just so clear and powerful. Digital twins are driving down costs, they're speeding up development, they're unlocking new innovation, they're making maintenance smarter, and they are cutting down waste in a huge way. It's basically a win on every single front. And you know, this isn't just a theory, it is happening right now. Huge amounts of money are being invested all over the world. You've got these collaborative hubs popping up, like the new UK Digital Twin Center in Belfast, that are being created for the sole purpose of pushing this tech forward. It's proof that this is a major industry-wide transformation. So, we'll leave you with this final thought. We've been focused on aerospace, but this technology, it could apply to almost everything. What happens when every car, every bridge, maybe even entire cities have their own living, breathing digital twin? What will we be able to create then? The possibilities are just staggering to think about.